Good morning again today, guys. How are you? Today we'll be talking about how to graph such a polynomial. All right? I'm giving you here an example. I'm going to call this graph g of x, x cubed minus 3x squared minus 9x plus 1. What is my target? To graph this line. So what I want is to graph it. In order to graph it, there are a few steps we have to know. We have to get, or we have to find, its critical stationary points. Is there a maximum point? Are there one or two? Maybe there's a minimum point. And once we do that, we look for inflection points. Is there a 1 point or 2 inflection points, or there is none? Once we can figure out these ones, it would be easy to graph it. All right? When we say graphing polynomials, I could have here x to the power 4, x to the power 5, x to the power 6. I don't have to have one intercept. I could have anything. All right? As far as to the power 2, 3, 4, 5, 6, anything. So let's start with an example and see what's the first step. My first step in this example, let's call it A. Let's find the stationary, there's another word for it called critical values, and then we call them the x. Remember, this is a solved example. It's in your lecture notes. You can see that thing probably in B and C. And in lecture notes D, it has examples, 8 examples. I've chosen one close from them, so I'll give you a chance to do the others on your own. And then we communicate through Microsoft, and we will sit together and discuss them as a group. And anybody has a question later on, it will work perfect, I hope. Who remember, to find stationary points, what do you need to do? If you don't remember that the first derivative, g of x, equal to 0, you can't find the first derivative. Finished. You made a big mistake. So let's take the derivative of that. All right? So the derivative of this is bring the 3 down, subtract 1 from the power, multiply 2 by 3, and then the derivative of 9x is 9, and derivative constant, as you remember, always 0. My first step, make a mistake, خلاص خربوط. Second step, you've got to equal this to 0. When you equal it to 0, this is an equation, and you should be able to solve your equation. And as I said in the earlier lecture, this is lecture number 2 about graphing functions. You have 2 options. In order to solve this equation, I'll remind you that quickly. Divide each one of those by what? By 2 or by 3 or by 5 or by 2, 1, 0, 1. You've got to divide them all by one number. That works for all. Then it's 3. As you divide the left hand side by 3's, you've got to divide the right hand by 3. Some people say, but I can take a factor 3. It's correct, but it doesn't make big logic. Anyway, when you divide this by that, 6x divided by 3 is 2x, and 9 divided by 3, it's a negative 3. And we all know this is a trinomial. How to factorize a trinomial? We open 2 factors. X squared, x times x. Give me any 2 numbers, their product is 3. It's gonna be 3 and 1. The sign is negative, means what? Different signs. But what does the sign mean? Go to the bigger number. Which is bigger number, 3 or 1? 3. Then that's opposite. So we have 2 options. Either this equals 0, which will take me to x equal 3, or means comma and x plus 1 equals 0, which means x equals minus 1, negative 1. Now I have two stationary points. This is my first stationary point. This is the stationary value, and that's a value. When I say stationary point, it means x and y. When I say stationary value, it means only x. I got them. Now some people say, oh, factorize. Oh, I don't know what to do. I hate it. Mr. Wild doesn't know how to teach it. Well, Habibi, why don't you go to mode and this, then press 5. 5 means equation. And this, if it is quadratic equation, press 3. You will see 3 boxes. Your equation is going to be written in this way, in descending order. You can't have anything on the right hand side. It has to be 0. The coefficient of x squared, we used to call it a in math 1. The coefficient of x term is -2. Every time you put a number, put an equal. -2, put an equal. -3, the constant, put an equal. You finish, put another equal. And what are you going to get? You're going to see two answers. X equals 3 and x equals 1. -1. These are your stationary values. What are they? It's a -1 and a 3. So gentlemen and ladies, you gotta know how to factorize. You must equal to 0. You should be equal to this. If you can't, nobody's gonna punish you. You are weak in factorization, but you will punish yourself when you go to degree. First course in degree, you need to know factorization. So suppose you don't like it, you can live with it, but later on you've got to do it. So go back to your notes in math 1, review it. You lose nothing. It takes only half an hour. And if you have a special problem, you still don't have a problem, why don't we get in touch with me on the Microsoft one-to-one? I can help you with that. We bring some paper and we solve together anytime during the day. I need to clean everything. So this was my first question, how to find the stationary points. All right, now, what is my second question? Second part of the question depends on this. If you have a problem with this, then the second part is bad. My second question is, find the intervals. My second part is, the question says, find all increasing or decreasing intervals. In order to do that, I want to know which part of the curve has a negative gradient. How many x's? From where to where? Which point on the same curve has positive slope, where the gradient is positive, where the first derivative is positive, and where it's 0. I'm going to use a technique, all right? This technique is going to be easy. It's in your notes. People show it differently. I'm going to draw a number line. That's a number line. I'm going to put my x values on it. This is x -1 to the bigger one, 0, 1, 2, until 3, and can keep going 4, 5, 6. Here, -1, -2, -3. All of these values are called the x values. So let me test you a little thing. Who can give me any point between -1 and 3? 0.9 negative, 0, 1, 2, 2.9. You can choose a 0. Just keep this in mind. Who can give me any value larger than 3? 3.1, 3.2, 4, 5, 6, 7, 8, 900 million. And who can give me anything below -1? -2, maybe. -1.1, -1.2, -1.5, -2, -3. So I'm choosing arbitrary values for some reason. Now, on the top of the line, I need to test the signs for the third derivative, or we call it to see what's the slope sign. Is it negative or positive? How can I do that? Why don't we take these values? Oh, by the way, remember, anything I'm going to write on the top is going to be the sign of the slope, the sign of the derivative. And you already know the sign here is 0. Remember? Because we said the third derivative equals 0. And the derivative here is called actually g, not f, but anyway. All right? So let's choose any value below -1. I've chosen x equals -2. Take this one and plug it in here, in the third derivative. Plug it in the, where's the second derivative? Where is it? Oh, we took it away. So this is my third derivative. 3x squared minus 6x minus 9. Plug this one over there. 3 times minus 2 squared minus 60 minus 2 and minus 9. Use your calculator. 9 by 3 is 27. 9 times 3 is 27. Actually 4, because minus 2 squared is 4. By 3 is 12. And -6 for -2 is negative plus 12 and minus 9. What really matters to me when those cancel out, 24, minus 9. What is 24 minus 9? Something positive. Maybe it's positive 13, positive 14, positive 12. I don't care. As far as anything I choose below the 0, it has its negative positive slope. How about if I choose the 0? Let's find out. What is the value of the slope or the third derivative when x equals 0? I can choose any value in between. Take the 0, plug it in here. 3 for 0, 0 minus 6, 0. What's the answer? Minus 9. So if you choose 2, or 1, or 0, or 0.5, negative 0.5, always the gradient is negative. And also the last step, if you choose anything above 3, such as the 5, plug the 5 in here, and guess what? Use your calculator, and the answer will be something positive. If you want the answer specifically, well, when it is positive, I don't have it here because I use a calculator. Plug in here, substitute in the third derivative. 5 squared 25 for 3 is 75. 5 times 6 is 30. 75 minus 30 is 45. Minus 9, it's 100% positive. So you may put as many positive as much as you can. Now, what do I benefit from this? Very secret. You remember what I said in math 1? That if a line is always positive, looks like this. And if any straight line always negative, goes all the way up to the left. And up to here, stop here. And if any line go positive, it means going all the way up to the right. So what I see here, I see a curve that I'm going up, stop, and coming down. I'm going down, I stopped 0, and then going up. And by doing this, I'm ready to answer part B and part C. So what was part B about? Part B was simply find all intervals. So if I'm looking for increasing intervals, and then find the decreasing intervals of this function. It could be 1 interval, it could be 2, it could be 3, I don't know. That's why I put it between brackets, because I'm sure I don't know how many intervals. Increasing means positive. Here's a positive. So everything below -1. Don't forget, this is plus. What do you mean below? Means everything for x that is less than 1. All real values of x. Anything. Minus 100.1. Minus the square root of 700. Minus 10, minus 7. Anything below 0. But actually, x is what? -1. So remember, don't copy things wrong. Oh, by the way, some people, because they finish high school in Kuwait, they write it like this. -1 is the biggest value, and you go all the way down. All the way down. So from the highest point to the lowest point. So which interval you like? It's your choice. Write the one you like. Is that the only positive increase interval? No. There's another one here. Look, that's 0. So you can say x larger than 3. You can write it in a different way. The smallest value 3 and gets bigger 4, 5, 6, 7, 8, 9, 10, all the way. Regarding the decreasing intervals, you can see it's in between. Between x equals -1 and 3. All of these are negative. So how do you write that? For doing this, we can either write it, all the values of x that are between, from the largest value 3 on the right hand side, the smallest one on the left. If you don't like this notation, there's another notation we can use from -1, not including, until 3, nothing. Don't write it like this. This means including. Nuh-uh, we don't want that. Once I'm done with all intervals, this will simply take me to the second step. What is my second step? Or third step? The inflection, the stationary points. What are the stationary points? Is there any local maximum point? Is there any local minimum point? Is there an inflection point? That's part C. Actually, the solution is in front of you. Why? When you go up and suddenly stop and you go down, that's a maximum point. Aha! Then my local maximum point, I can see it, is at what? At -1. Uh-oh. There's a point. When you go all the way down, you stop and you go up. That's called a local minimum. This is x and I don't know. How can I find the y? Simple. Do I substitute the x in the derivative or in the original? I know you all know that. We go to the original one, g of x, and substitute -1. Substitute it there. -1 cubed, and then -3 squared, and the -9 times -1, and then +1. If you do all of this, I did my homework actually, so I don't have to waste your time. It is 6. So write 6 here. Do the same thing with the 3. Substitute, and the answer is 26. So now I find the coordinates of the maximum, and there is no inflection point at that stage. And guess what? Why I call it local maximum? Because there's something else higher than that. Why do I call local minimum? Because there's something else less than that. I did not restrict myself to any kind of interval for that function. Now, all this much, it's been done for what? For taking the third derivative. What happens if I want to go for finding inflection points? Which kind of inflection points? The inflection point that happens due to change in concavity. So what is my question? My question D says, let's find intervals of concavity. What do I mean interval concavity? It means you could have a curve that is concave upwards, or it could be concave downwards. How can I do that? You already got half of the answer. Remember when we did the third derivative? What was it? 3x squared minus 6x minus 9. And remember, in order to find the concavity, your second derivative gotta be equal to 0. This is your key. You forget the key, everything is not good. So let's do the second derivative. 3x squared is 6x minus 6. You gotta equal to 0. Equal to 0. You want to solve it, you've got to do it. Divide both terms by x, x equals 1. This point, we're good. We may have an inflection point. How can I test it? I want to find a test, a way to do it. There are 2 or 3 tests. Like when people test you for corona, they put this in your head to find out if you have a temperature. Now, in order to find a test, we need to know. I'm going to do the same business. Draw a number line. I'm going to put all values of x. What x I got? Oh, I got 1. This line is not the first derivative, it's the second derivative. Remember, this line is the second derivative. It's the gradient of the gradient. The first one was called the third derivative, rate of change. This is the rate of change, or the second derivative. And who remember what is the second derivative is this? Let's do the same business. Choose a few points below and larger. Anybody can give me anything above 1? I can use 2. Plug it over there. 6 times 1 minus 6, it's what? Actually 2. Positive 6. Oh, my second derivative sign. Above the 1, here is 0. Remember? Second derivative equals 0. I found 0. How can I find 1? By equate to 0 and then the answer 1. Anything above it is positive. You know what does it mean positive? Thanks God. It means you are so optimistic. This is called concave up. Take any values below 1. I can take 0. So g of 0, 6 times 0, 0 minus 6 is a negative. Oh, anything below 1, the sign of the second derivative always negative. It means you are pessimistic. Oh, I'm not happy. Look at your hand. It's going down. When your hand is going down, it's negative. Oh, guess what? I've got some answer here. What's my answer? There is a change in concavity to the right-hand side of the 1 and to the right-hand side of the 1. X equals 1. To the left of it is negative. To the right of it is positive. There is an inflection point. Oh, so the answer to part D, what are the intervals of concave up? You can see it there. All the values x larger than 1, or you can say 1 and infinity. What are the interval or intervals of concave down? You can see it here, x less than 1. You can write it if you wish, like this. Some people say, why I'm leaving this one here? I need it for a minute when I graph. My second part of the question, E, it says find the point or the coordinates of inflection. Well, the point is ready. The first one is what? It's the only one. It's 1 and something. How can I get its y? Go back to the original function. Some people say, I forget. Don't forget, you had this in math 1. Plug in the 1 in the original function. So 1 cubed is 1. Minus 3 times 1 minus 3. 1 minus 3 minus 9 and 1. 1 and 1 is 2. And minus 12, it's a minus 10. Am I right? Let's see, because sometimes I do stupid mistakes and anybody, yes, actually, it's minus 10. All right? So the coordinates of the inflection point, it's 1 and negative 10. And guess what? I've got a perfect thing. I'm done. Simply have to go to part A, B, C, D, E, part F. What is part F is about? Check your lecture notes. I don't do this for nothing. I did all of this for one purpose, to sketch my graph. So part F simply is graph the function, graph the curve. Don't forget, we are sketching, but values are exact. Some people has his hand like this, some people are smooth with curves. It doesn't mean you're not good, but you are giving the right answers. Let's draw my x and my y axis. All right? So why don't I summarize what I have there over here? My local max, minus 1 and 6. This is for me. My local minimum, it's 3 and 26. My inflection point, it's in 1 and negative 10. Why I'm doing this? So I'm gonna clean this part. If you did not understand what do I mean by change in concavity, it's your chance now to understand how I'm going to use that. This is your x-axis, and that's your y-axis, and that's your origin. You can see the x is between 1 minus 1, 3. So I simply can say, this is 1, 2, 3. I don't need to go more. And I can go all the way down to negative 3. Yeah, why not? I can do that. But guess what? This is going like 10 or 30 or 40. So why don't we do it in terms of tens? So this is like 10, 20, 30. Some people say, oh, I know it in advance. You can say 5, 10, 15. If you say 1, 2, 3, 4, 5, 6, it's going to be ugly. And then you can do the same as far as you want. Minus 10, negative 20, negative 30, and negative 40. All right? Let's plot the points. Just plotting. Negative 1 and 6, where is that? Some people do go down here. Be careful. This is 10, this is 5, this is 6. So this point is called what? A maximum point. Maximum means go up, then go down. Well, why don't I write this coordinate on the graph? Negative 1 and 6. Where is my minimum point? 3 and 26. Whoa, this is 25. This is 3. This is 25. Go down a little bit and call this a minimum point. So what's the coordinate here? 3 and negative 26. Where is my inflection point? At 1, negative 10. This is my 1. Where is my 10? Here. Somewhere here, there's an inflection point. That's called 1 and negative 10. Now, I depend on your smooth your hand. Look, I'll go all the way up. Look at concave up. Suddenly, I've got to change it. Concave down, passing through this one. I'm not that bad. And then make sure, don't just stop here. Go all the way down like this. The best is, should I go here or here or here? I'll give you a secret and you know it. This going all the way up. So you're crossing somewhere here. You learned in math 1. You learned in math 1. In order to cross that y-axis, x equals 0, or this is the y-intercept. Ta-da! This is 1. Oh my God, I'm so good with that. If you want to finish, if you want to do the x-intercept, so remember, to find the x-intercept, y equals 0. Go to your calculator. Mode 5, 4. Mode 5, 4. Enter the following numbers. 1 equal, negative 3 equals, negative 9 equal, 1 equal, and then equal. And guess what? You're going to have 3 answers. The first answer, where you intercept, is x equals 4.8. The second answer, it's a 0.19, I believe, 1. And the third x-intercept, it's a negative 1.93. This one. Now you are having a very nice sketch of your graph. If you want to make sure and you don't want to give yourself a hard time, why don't you check it out with www.desmos.com/calculator. Remember, we use that software a lot in Math 1. Put it there, enter the equation, double check. Oh my God, Look it up, it's there. This is not beautiful. Okay, let's make it beautiful. خلاص. So this is called an inflection point. And that's inflection point. Just before it, you concave up. Just after it, you concave down. When there is a change in concavity, when the second derivative is positive here, up, and when the second derivative after it is negative, because you're concaving down, and the second derivative at that point 0, not the gradient, the second derivative, then that's an inflection point. Maybe you will find, there must be a reason. Whenever there's a maximum, minimum, there must be something in between. True. You will have always, not sometimes, always an inflection point between minimum, maximum, maximum to minimum. Okay, guys, I hope that you go through it again. My advice to you, write it down, go slowly, use the pause, write it down, pause, write, and see it. And if you have a problem, go back to your lecture 1 of this chapter, chapter 6, because it has 4 lecture notes, A, B, C, and D. Inshallah, next meeting in section 3, I will choose another example. All right? This example is close from this. What I will do with that, I will then, after that, give you homework. So don't do your homework. Your homework is to look at these notes and put them together. Lecture 1 and lecture 2. Put them together. All right? Inshallah, when you do that, you will understand 60%, 70%. Some people can pick up to 80%. Some people, they say, too hard, too fast, the teacher is not speaking English properly, blah, 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 blah. My advice, we can discuss that on the Microsoft during your office or during your scheduled time. If you class from 8 to 9, be there 8 to 9, 3 times a week. If you class between 9:30 and 11, be there twice a week, Monday and Wednesday. All right? And if you need to use my office hour, you know it, every day, 11 to 12. All right, ladies and gentlemen, have a nice day. Sorry for that. I hope I was a little bit better this time. Thank you, thank you, thank you.